Okay, in this video we're going to learn how to factor what are called perfect square trinomials. But before we learn how to factor here, we need to know the forward process of this. So factoring is actually a backwards process. Let's learn how we can actually come up with a perfect square trinomial going forward here. So when we factor a perfect square trinomial, these examples right here, these quantities squared, so like the first one, I would say this is 2x minus 7 quantity squared. That's the result of factoring a perfect square trinomial. So let's look at the forward process of actually how we can get a perfect square trinomial, and then we'll look at how to go backwards to factor it. Now, 2x minus 7 quantity squared, well, when I square something, it means I multiply it by itself. So I could expand this as 2x minus 7 times 2x minus 7. And then notice from there, I could do the full method here. So doing the full method here, the first would give us 4x squared. The outside would give me negative 14x. The inside is going to give me negative 14x. And then the last, negative 7 times negative 7, will be positive 49. Now, notice in the middle here that negative 14x minus 14x, it doesn't cancel out there. They're both negative, so we'd actually add them, and we would get negative 28x plus 49. Okay, so now this 4x squared minus 28x plus 49 is called a perfect square trinomial. We'll look at the details of that in just a minute. Now, that's sort of the long way of expanding a quantity squared. And so when I was probably your age here, that's the way I would do that, because I didn't understand the shortcut that my teacher showed me. Now I'm going to show you the shortcut, and hopefully I think you'll be able to understand the shortcut probably a lot better than I did when I was your age. So I'm going to erase this and show you a quicker way of expanding a quantity squared binomial. Okay, so one of the things you probably want to write down here is just a little pattern to help you remember this. Okay, so we're going to say this when we do it. We're going to say square, double, square. Okay, and we'll say it really fast when we do this. So we'll say square, double, square. Okay, so here's what we're going to do. We're going to take this and we're going to square it. And so when I square 2x, it's not just 2x squared, but it would be 4x squared. Okay, and now double means I'm going to actually take the 2x and the negative 7, and I'm going to double the product. Okay, so one thing about the double is we're doubling the product of the two numbers, which means I would multiply. Now that's the hardest part. Now notice, since this is negative, this is going to be negative. Okay, so let's get that out of the way. And so when I say double, it means I'm going to take these two terms, multiply them, and double them. So 2x times 7 would be 14x, and 14x doubled is 28x. Okay, that's really the hardest part about this shortcut, is to kind of catch on there. Now, so there's square, double. Now, square, negative 7 squared would be a positive 49. And I think here, perfect squares should always be positive. They can never be negative, because when I square something, even if it is negative, it has to come out positive. Okay, now if you didn't quite catch on to that, let's look at like 3 more of these. Okay, so we're going to say square, double, square. Okay, so 3x squared would be 9x squared. Now, double the product. Now I'm going to go ahead and get the sign. It's plus sign, so that's going to be plus right there. Okay, so 3x times 4 is 12x, and 12x doubled is 24x. Again, that's kind of the hard part. So square, double. So I said 3x times 4 is 12x, and 12x doubled is 24x. And so now square, double. Now square 4, and then you would get 16 there. Okay, let's try the next two. So here we go. Square, that's going to be 25x squared. Okay, now it's going to be minus. Okay, now double the product. 5x times 6 is 30, and 30 doubled would be 60. So it'd be 60x there. And then square If I square negative 6, it would be positive 36. So notice your perfect squares are going to end up on the ends, and they're always going to be positive because you're squaring something. And if my sign happens to be negative, well, that's just going to go right there. Just the way, oh, I messed up on this one. It should have been negative. Ooh, sorry about that. So, oh, I was looking at the wrong one. That was positive. I was looking at the previous problem. All right, that's right. And then that's what I was looking at. So that was minus. That one's going to be minus. All right, let's look at this last one here, and then we're going to learn how to identify a perfect square trinomial when we see one. All right, so square, double, square. So squared would be 9x squared. Now, it's going to be plus, because that's plus. Now, double the product here. Square, double, square. So double 3x times 7 would be 21x, and 21x doubled would be 42x. And now finally square. The square of 7 is 49. Okay, now that's the forward process, two different ways. And let me kind of reassure you here, if you did not understand the square, double, square, okay, I certainly didn't when I was your age. So I would always just do this. I would just do 3x plus 7 times 3x plus 7, and then just use the full method, and it arrives at the same thing. Now, let's look at identifying a perfect square trinomial. So I have three things here that we're going to have to sort of ensure that we have a perfect square trinomial. Now, this model here is the model of a perfect square trinomial. Now, that looks kind of complicated, but when when you see the numbers behind it, it's really not all that bad. Okay, so first thing about it here, before we can have a perfect square trinomial, the a and the c. Okay, so that's going to be the first and last terms. Okay, let me just write like that. First and last terms must be perfect squares. Okay, so that's where we get the idea of the perfect square trinomial. The first and last terms, they have to be perfect squares, and usually that's what's going to give it away there. Now, the other thing, to really be perfect squares, they have to be positive. Okay, so there's the other thing, is that a and c, we could say the first and last terms. Okay, let's just say that again. So first and last terms must be positive. Okay, so the a has to be positive and the c has to be positive. If they're not both positive, okay, so in other words, this sign right here, that has to be plus. Okay, and I can't have a negative right there, or I can't have a minus right there for it to be a perfect square trinomial. Now, here's probably the most confusing part. It's the middle term. Okay, so the middle term, and this is really, really hard to illustrate without numbers here. I'm going to probably throw some numbers into this in a minute. That's not how you spell middle. Okay, so the middle term has to equal, okay, 2 times, I'm going to write it this way, times the square root of the a term. Since it's a perfect square, that's going to be a nice number, times the square root of the last term. Okay, now that looks really confusing here, but when we put the numbers behind this and we write the numbers down, I think you're really going to see that. Okay, now let's look at some examples here, and let's concentrate on identifying them first. So that's the biggest thing about perfect square trinomials, is identifying them. They're actually very easy to factor. Okay, but we have to be able to identify a perfect square trinomial when we see it. Now, usually the clearest thing is going to be the first and last terms being perfect squares. And then we have to dig in and really kind of, not isolate, but really focus on the middle term to see if it's going to come out the way it should. All right, so we're going to identify each perfect square trinomial and factor. Now, in a minute, I'm going to do several examples there with you. Okay. In a minute, you're going to do the same thing with the 6 little practice problems right there. So when you do these, first we're going to identify if it's a, I'm going to abbreviate here, perfect square trinomial. Okay. And if it's a perfect square trinomial, we're going to factor it. But if it's not a perfect square trinomial, for now, we're just going to leave it be. So if it's not a perfect square trinomial, then we're just going to write, hey, it's not a PST. I don't know how to factor that yet. Now, so let's look at the first one. Okay, now, the first one is a perfect square trinomial, so we could have a nice one to start off with. Now, let's look at the condition. Okay, so I hope you wrote down. If you didn't, you might want to go back and write down these 3 bullet points right here. Okay, and that's what's going to identify it for me. So the first and last terms have to be perfect squares. Okay, so notice that is true. The other thing, to be perfect squares, the other thing is that they have to be positive. So notice the 25x squared is positive and the 64 is positive. Okay, so far so good. We've got 2 of the 3 things. Now, here's what I'm going to do to check that complicated middle term. All right, I'm going to look at the square roots of the A and the C, so the first and last. And what I try to do here is I just kind of write it lightly, you know, write it lightly with your pencil there, above it, what the square root would be. So the square root of this here would be 5x. Okay, 25x squared, the square root would be 5x. And then the square root of 64, I'm going to do the same thing. I'm going to write 8. Okay. Now, so what I've done in my model here is I've taken the square roots of those numbers. Now, if I take those numbers and I multiply and double those, it should give me the middle term. So take a look at that again. If I take the square roots of those numbers and multiply them and double, it should be the middle term there. So let's see if this works. 5x times 8 would be 40x. And 40x doubled is 80x. Okay? And so the middle term is usually the thing that you really have to focus on to see if it's a perfect square trinomial, because you're probably going to recognize the perfect squares on the end just fine. Now, since this is a perfect square trinomial, I can factor it. So let's talk about, this is the easiest part, is actually factoring it here. So when I factor this, the factors come out like this. It's only one factor, and it's a quantity squared. Okay, so it's not 2 different factors like a lot of times that we've been factoring. Now, the 2 things that go in there are the square roots that I wrote above the numbers. So 5x and 8. Okay, really easy because they're perfect squares. Notice the middle term doesn't really even come in when I factor it. The middle term is for identification purposes only. Now, as far as the sign is not necessarily positive. The sign is going to be whatever the first sign is. So whatever the first sign is going to be the sign in your factor. And that's it. I've factored a perfect square trinomial. So notice, again, the most work in a perfect square trinomial comes from identifying it. Okay, let's move on to the next one now. Okay, so let's go through our checklist. All right, so perfect squares on the end, check. Are both of them positive? Check. Okay, so now, there again, it's all about the middle term. So above them here, let's write the square roots of those 2 numbers. So the square root here would be 3x, and then the square root here would be 7. Now, if I take those 2 numbers, the 3x and 7, and multiply and double, it should give me the middle term here. So let's see. 3x times 7 is 21x, and 21x doubled would be 42x. Okay, now, I know you're worried about, hey, well, it's negative 42x. Disregard the sign in the middle. Okay, it really doesn't matter. Notice on my model right there, notice that I had plus or minus. Okay, so that sign really doesn't matter until I factor. Okay, so disregard the first sign. Now, so again, 3x times 7 is 21x, and then 21x doubled is 42x. So it is a perfect square trinomial. So here's what the factor is going to look like. It's just one single factor, and it's a quantity squared. And what goes in there are those square roots that I've written above those numbers. So it's 3x and 7, and the sign that goes in between them here is whatever the first sign is. So notice the first sign was negative, so that's going to be negative right there. Okay, they're actually easy to factor. Now, let's look at the next one here. Okay, so let's see if the first and last terms are perfect squares. So what about 8x squared and 81? Are those perfect squares? No, they're not. Okay, 8x squared, 8 is not a perfect square. Okay, so we're going to look at ways to factor this later. But for right now, we're going to leave it. You're going to have something like this on your next screen here. This is not a perfect square trinomial. Okay, so we won't worry about factoring. All right, let's move on to the next one here. So in our next one, let's see, perfect square. So perfect square, check. Okay, are they both positive? Check. They are both positive. Now, let's write their square roots above them. So the square root here would be 2x, and the square root here would be 11. Now, if I take those two numbers and double it, it should give me the middle term, and you remember, you don't worry about the sign on the middle term. Okay, so 2x times 11 would be 22x, and 22x doubled would be 44x. Well, I don't have 44x in the middle. What happened is I think they doubled this one twice here. Okay, so again, 2x times 11 would be 22x, and then 22x doubled would be 44x. Okay, so what had to happen there is this really needed to be 44x in the middle. So this one is not a perfect square trinomial. Okay, so again, you know, the telltale signs are going to be the perfect squares on the end. That's what's going to alert me that it may be a perfect square trinomial. But the middle term has to work out perfectly there. Now, let's look at these four. All right, so very similar problem now. We've got perfect square, check. Now, are both of them positive? Oh, no, they're not. Okay, so the thing is, I know we disregard the first sign, but on this one, negative 121 is really not a perfect square. Okay, so you can look at it kind of two ways here. You know, 11 squared is 121. Okay, negative 11 squared is still 121, because when we square a negative, it becomes positive. So a perfect square cannot be negative. So this is not a perfect square trinomial either. Okay, let's look at this one now. So now I think everything should be right here. So perfect square, 2x and 11. Are they both positive? Yeah, now they're both nice and positive there. Okay, now let's check the middle term again. So if I multiply this times this and double, it should be this, and the sign don't matter. So 2x times 11 is 22x, and 22x doubled is 44x. So that worked out. So now, let's factor. Okay, so the factor turns into a quantity squared, and we put the square roots down that we wrote above there. So 2x and 11, and then the sign that goes between them is whatever the first sign is. So I just take that first sign and just bring it down, basically. Okay, and 2x minus 11 quantity squared. And of course, we can multiply that out if we wanted to check it. Okay, or we can use our shortcut to check it. Okay, let's look at the last two. All right, so let's see. Perfect square, and they're both positive. So far, so good. So here we go. We got the square root here would be 6x. Now, 1 is a perfect square. The square root of 1 is 1. Now, 6x times 1 is 6x, and 6x doubled would be 12x. So everything's like it's supposed to be here. So this is going to be a quantity squared. Those two numbers are going to be my factors. And I'm going to take the first sign to go in between them. Okay, let's look at the last one now. Okay, let's check our perfect squares here. So perfect square, perfect square. Okay, they're both positive. Now let's check the square roots and see if the middle one turns out. So square root here is x, square root here, square root of 225 is 15. Okay, you may not have known the 225 thing. Now let's check the middle term here since they're both positive. Okay, so we're going to multiply those two square roots. Multiply x times 15 and double it, and it should give me the middle one. X times 15 would be 15x, and 15x doubled is 30x. So that's okay. It doesn't matter that that first sign's negative. So now my factors are going to be the x and the 15, quantity squared, and then the minus sign, the first minus sign is just going to be in my factors there. Okay, now you have 6 of these here that I want you to try. Now they are not all perfect square trinomials, so if they are not perfect square trinomials, you can write for me not a PST and then move on. You don't have to factor the ones that are not perfect square trinomials there. Okay, so you can pause this and try those out now.